Are we live? Let me see. It looks like we are live. Okay, let me share the link, guys. So we're continuing to analyze the Opus download script. And that's streaming right now, going through the Opus download script, and we'll be downloading the 8VCS data. That's the plan for this stream. So let's go. Just turn on the live chat. And we're ready. Let's continue where we stopped. So we are analyzing this Opus Read script. Basically, we got to the point where we downloaded a couple of these alignment and raw data files for this particular corpus that we are currently downloading. So let's just analyze what happens in this store sentences function. So we pass in the document, which is a zip file, English to Croatian XML here, with a data tag set to S, which is, I think, just a representation they use for raw data, whatever that means. I'm not sure about all of the details. And then current position 0, verbose true, get the complete blocks, and then they parse block by block and get a sentence. Let's see what they get here. So this is it. So the block name is raw and the attribute of ID is in the ID set. In that case, we parse the sentence. We pass in the block, the sentence, which is currently empty, and sentences. And so this is going to probably be populated by this function. Let's see. We grab the ID, block data strip, append to the sentence, slowing the spread of the virus, and then we join with space, which will probably do nothing because we just have a single sentence. Yes, and then we basically add that sentence to the sentences given the ID, and we put in the attribute as well as a tuple. Okay, so that's how this is going to look like. So it's now just parsing through these files. We can remove this breakpoint here, and we just keep on doing this, and then get complete blocks, and then we just keep on recurring here. So let's just go to the very end, close down this, and see the sentences. Let me just see where is the data we got. I think we stored it internally inside of the document. So maybe let me see here quickly. Okay, this just closes down the document, reports the progress, prints, and retrieves back the size of the doc, which is 44,000 apparently. Okay, let's continue. We do a similar thing for the other. This is the target direction. So let me just see one thing. We downloaded to Opus. We have these two files. We have the raw English zip and raw Croatian. I think the last one was English, likely. Let me just see here. Can we actually see the name? Yes, this is gonna be raw English Croatian is the name. But what's the actual file we are extracting for? I think it's gonna be this file here. I'm not completely sure, but we're gonna see soon. I can always unzip this and check it out myself. Let me just try open up this. If we extract this here, just open it up, see the file, here it is, and then so there is a ton of these different ones. So we were looking for English to HR, this one, and let's see the number of lines here. Okay, the number of lines here is very small, only 298. So this might be bytes. The size might be in bytes. I'm not sure. Let's see. And then we also have, let me delete this. This was the English. We can also check out the Croatian version. Let's enter here. Raw. And here we have, again, around 300 something of these sentences. Let's go back to where we stopped. So this one is English Croatian. This is kind of misleading because they're not processing that particular file. Let me exit here. Go and call the store sentences. So I think this one returns back the doc size. So this returns, I think this is going to be in bytes or something. So let's do that. And then once we are done there, now we do what? So add document names, this one, and this one. And result file. Moses target. Let's enter here. Let's see what this does. Okay, nothing. And then length 288. Link list. Okay. So we go through the link list. Whoops. Just a second. I kind of went too fast through that. So we were here. We were in the format pair. Grabbing the link and the parsers. We are now constructing the parallel data. So we went there and then we went into the normal and then we just went into read sentence. Okay, let's see. We go through the IDs. There is only a single one. So we get the sentence from the sentences, which was stored inside of those parsers. So here's the sentence, and we append the sentence, and we append the attribute. So it's ID. And we go back, and we do the same thing for target. I think we can just remove this. So we get the sentence from the parser. We can remove all of this. Let's exit. So we get the sentence back. And then if check filters, which I think just returns always false, in that case, we call format sentences and we pass in source. And that's just going to add the new line here. So here's the result. We retrieve that back. We do the same thing for target, and let's go back. So now we have them formatted. You can see we are forming the parallel corpus. And so if I is smaller than the attributes list, in that case we grab the actual ID, I guess. Otherwise we retrieve none. And then output pair. This is probably gonna just save to the output file. Let's see here. What happens here is, okay, yes. So we strip the new line. And then if there is any other new line, we replace it with a space. So we get pure sentence, and then we grab argument number 2, which is going to be the output file, and we just paste in the sentence, which is in English, and then tab, and then this. So this is going to be the output format. And then if total equals maximum, which is never going to be true because this is set to -1, which means there is no max. And now we just keep on doing that. So again, format the pairs given the link, and after we're done doing that, we just put that line here to the output. Okay, we can hit F5 and just skip to the breakpoint, and then here we don't do anything, and then finally we just print. Okay, this is just some progress update, and that's it. I think this should be it. Just a second, we started from print pairs. We were in here, then we were doing this, and now we are back to the while loop. We report the progress, go back, there are no more blocks. Let's see what happens here. We should probably just break here, yes. And at the file ending, again, nothing because this is just Moses. And then document close, we just close the file. That's it, we don't have to go this deep. Let's continue, and if write Moses and this is specified, which is not, otherwise we just close the result file and we close the zip files. And that's it. So that was the whole process. So that's what it looks like. It basically downloads these XML files, it parses them, and then uses that to construct the final Perl text. That's it. Okay, so we now understand how this works. And it looks like it makes sense. So let me see whether we want to change anything here. I don't think we want. We just want to specify maybe not specify the corpus and see what happens in that case, because ultimately we want all of the data. We don't want to be discriminative on the type of corpora we take. Let's go back here. So Creation, as you can see here, has a ton of different corpora, so we don't want to specify all of them manually. Interestingly enough, we won't even need to use OpenAI's NLB, sorry, the LNAI's NLB, because Opus has obviously already processed that. And it's here. So most of the data comes from a couple of these corpora. It's a very significant power law, 112 million. Here we have like what, 36, 37, it's already 70 something, 80 something already here. So bulk of the weight of the corpora of the corpus is here in these 5 main corpora. These are mined, CC matrix from Meta. This is also mined. CC aligned is, I think, also mined. Paracrawl, Open Subtitles, it's not mined, but I think it's very noisy. But okay. Let's see what happens if we specify directory set to none. In that case, what will happen? If directory is set to none, okay, I don't see, it's probably gonna fail. I didn't see any logic that would allow us to handle the directory set to none. Here we're trying to join, and it's gonna fail there. Same here, none plus. A bunch of these zip paths and paths are gonna be completely bad. And then trying to open the alignment file will fail. Let's quickly try it, but I'm fairly sure it's gonna fail. So if we stop this, if we specify none here, let's see what will happen. I'm gonna hit run. Okay, we have to delete this data. And let's rerun. Okay, let's enter inside here. Let's see where directory is called again. So here, let's see what happens when we try and call with none. Yeah, it fails. Yeah, it's definitely not meant to be used like this. So that means, why can't we just specify source and target? Let's see. Opus tools. Let me see which files they have here. Opus data. Init. I did see in their GitHub issues that they should support this type of download of everything. Let me see. Okay, download all with just the S switch. I don't think it's this one. Is it possible to download all corpora? Yes, you can do this with the Opus get script. For example, you can first list all corpus files and then download them. So Opus get apparently should work. Let's see. Are we using Opus get or something else? I forgot already. Let me just check. Download Opus. We are using Opus read. Okay, what about Opus get? Where can we find Opus get? Let's just open the file directly. Here it is. Opus get. So how does Opus get work? Init. Okay. So Opus get will help us download the files, and then we can use Opus read to just parse all of that. So that should do it, because I don't want to manually go through the website and figure out what I need to download. That's going to be terrible. So because of that, let's go here and just specify, as we saw up there, let's just specify S and T like this. Source and target. Let's try that, guys. Opus get. Comment this out. Or maybe rather than doing that, let's just go up there and just directly call Opus get. Let's just import from Opus tool this one, and let's specify source, and that's gonna be English Croatian. That's cool. I think this should be it. And then we have to call what? Format size, get response, get corporate data. Probably get corporate data. Download. Get files. Let's see. When we were using Opus read, we did call Opus get. Let me just see where exactly. Opens file handler. Yes, Opus get was used here. And then we were just calling get files. Target. Source. Huh. And here, did we call anything here? Alignment parser. Do we have Opus get here? Opus get? Nope, we don't. So all of the logic was inside the handler, and then there is the parsing. So everything that happens here, and this guy calls Opus get. Okay. Let's see what happens if we just call it like this. run, enter. Okay. So directory, yeah, because let me see, target, source, release latest, preprocess XML is set here. Why did this fail? Aha, because we didn't call it correctly. We just need to pass in source like this directly and target as well, just a string. Let's stop this and let's rerun it. We just put the breakpoints over here, maybe here, and run. Okay, here we are. We got ourselves an URL. It says Opus API source target. Corpus is not specified. When did this reply happen? That was in August 26th, 2022. What else do we have at disposal? This doesn't look like read Opus data. What's this? Is there anything in here that will make us grab the corpora? Get corpus data. Download, given the corpora. Where is download called here? If anywhere. Download. Okay, it's called here in the get files. And are get files called anywhere? Nope, they're not. And download is only called down there. And then get corpora data is called here. Okay, so I guess we just want to call get files. Let's see what will happen there. So if we say get func get files, let's stop this and let's rerun this. Hit the 5, get to get files. If list languages, no. If list corpora, no. Otherwise, download this. Get response. Will this fail? Yes, it will. And we're done. Okay. And then you try and download, and this is just gonna fail. Okay. So we can't just specify source and target like this. There must be something. Parsers, get read cat. All. Is there any mention of all corpora? Print all available attributes. Maybe we can just list all and then iterate by doing that. That's gonna be the alternative option. We're gonna list everything that is inside of this. and then we're gonna pick up the names of the corpora. I think that's the best way we can do this, apparently. I don't see any other way. Okay. List all files. List all files. Opus get. Okay. Let's do the listing. Let's go back here. Opus get. List languages, list corpora. Let's set it to true. So if we go here, if we list this to true, okay, and then directory is this. What did we have here before? Let me just quickly check the script. I think I've sent it somewhere here. So we had the script here, and here we had just corpus. So just name of the corpus should be here. We don't want to specify that, so let's just go like this. Rerun. Enter. List. Okay, get response. Corpora set to true. So source English, target is going to be Croatian, version is going to be latest, pre-processing XML for now, whatever, and then get response. Will we actually get some response here? Okay, nice. Here it is. Okay, there is a ton of corpora, and let's just compare that side by side. If this works, guys, then it's going to be super easy. So, wow, there's a ton of data here. How can we go and compare this? Is this sorted? Okay, this is definitely sorted, but the data here is not sorted. Okay, so data here is not sorted alphabetically. At least corpora is not sorted. What should we do here? Bible. Well, let's go step by step. I don't know what else to do here. Give me a second. Let's print the length of this. Print the length of the corpus list. Just see this, and that's 86. The quickest thing we can do is just count this: 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 is here, and then 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 on the legal part. 31, 32, 33, 4, 6, 5, 50, Croatian Bank is 51. $60, 65, 70, 70. Okay, roughly. I counted 85, but it's not impossible. I made a mistake. I'm a bit tired. Didn't sleep really good last night. Not enough sleep. Let me see. Do I want to really count this up? Why didn't he just have an index here, like at least if he didn't sort it? Oh my god, why? Wait, I have to count this again, guys, in myself. So 5, 10, 13, 15, 18, 20. 20 is at press corner COVID. And then 3, 25. 30 is on legal. 40 is on mine action. 50 is here, 2 to 6. 60. 70 Elra. Snap my life. Which Elra? Which one was it, guys? White. Oh my god, there is so much Elra. Oh my god. This is just hopeless. My brain is so much not working. I need my notes here on the side, and then let me go from the record here and then see whether we hit Elra after 16. If we hit Elra after 16, that might mean we're good. 3, 6, 9, 10, 13, 15. So it is 85 apparently. I think it was this Elra. So we have 15 here. So 85, but we found 86 here. Are all of these valid? Can you just grab source here? Okay, can I grab any of these? Where can I find these? I'm gonna do it algorithmically, literally. So here it is. Table rows. Table rows. Input checkbox, show all versions. Table row. To download the data. Let's see how we can parse this easily. CC matrix is the first one. Open subtitles like this. Okay, it's here. And that's the table TD. Okay, I think we can just grab a table. Okay, let's just do one simple thing, because we want to spot any of issues like this. Beautiful soup HTML parser. You can just parse it like this. Let me just ask ChatGPT, given a URL and a beautiful parser, but how do I extract all tables from a given page in Python? Let's go, guys. Let's go. Using ChatGPT to solve this. Let me see table. How many mentions of table? we might have multiple tables in this, but we'll be able to filter out only the one that we need. And I think this is the one we need. Okay, so let's go. Let me quickly write down a script that is going to compare the results here. So ideally, I'd love to, instead of this, doing this, I just want to get back the corpus list as well. I'm going to modify this file locally. And then here, because we set list, we want to have a corpora list, and then we can print it if we want. Okay. Let me modify this code. Let me just install Beautiful Soup. Pip install Beautiful Soup. It seems as if it's not really, oh yeah, it is. Okay, might just need to do something like this. Clear on the activate NLB. This is all because I'm tired. I'm using code to make sure we can scrape and get the names in of the rows and compare them against what this script is giving us. So that's what we're trying to do. So I installed this. Let's now see what ChatGPT told us. So I'm going to create a helper function that get corpora names for language direction, and I'm going to pass in a URL, and then we're going to do the following. So first of all, we will also import a couple more packages, and then fetch the website content and parse it using the script, something like this. And then let's just delete this because we pass in the URL. Find all table elements using the find all method. Now the table variables contains a list of the table elements. You can then process these tables as needed. Let's see whether this does the job. Okay. Let's see whether this will work. So go here and pass in the URL we were looking at. Well, the thing is, nah, this will not work because it doesn't have any different URL. It just does internal logic. I would have to, could they pass it this? Would this work? It's kind of hacky, but if we can get it to work, oh no, this is not going to work as well. Can I just parse the document somehow? Use pass HTML content. We might be able to just response text. Why not just, well, I can do the following. I can just copy this whole thing, or copy just, no, I can copy the whole thing. Quickly put it here. Save it in here. Yep. Whoops. And then copy the path there. And then we don't even need a URL. We just need HTML path is this. Load data text from HTML path. Just open it up as a read file, read that, and then I think we can just pass in this text here, and this might work. Let's see. Comment this out. Run this. Stop the script. Run this. Okay, just open it up. Here's a piece of text. Will this work? It looks like it does. Tables, 7 tables. Nice. Now let's see. If we just print this, we get the actual table. Okay. Nice. Okay. This was kind of hacky, but it worked. Let me now see. How can we distinguish between the tables other than the length maybe or something? I think that's the right one. There is no name or anything. Table row corpus, blah, 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 blah. That's the longest table. Let's just find the longest table quickly. What's the length of a table? If we just go here, and if we do length, what will I get? Okay, let's find the one that's longest, and then let's just parse it. And after we get that, we are sure that the scrape data corresponds to what the script gave us from the Opus tools, and then we can iterate through that corpora list and just keep on downloading one after another, and then that's the easiest part. Then we just wait. Okay. Is there any feature I could use to basically, well, probably some of these fields like other files, you probably mentioned only once, yes. So if any of them have other files, can we just iterate through the table? Like, can we do like table of 0? No, I can't. So what's the type of table? This is just a tag. Okay, so given a tag, how can we, let me open up ChatGPT again. Let me just continue the last conversation. So given a table, how can I check if a certain string is present among the table's rows? What's the easiest way to do this? Okay, so we have a table, and then find all of the rows, and then find the texts. Okay, fair enough. That's what I want to do. It seems reasonable. So for table, we don't want to prettify. We just want to, whoops. Let's go here. We go through the table rows. We get the row text like this. And then if this is present, target string, okay, which I'm gonna set as we saw previously, it's gonna be other files. If this is present, in that case, we just, yeah, we can then just do this. for now, let me just double check that works. Just print the table. Otherwise, don't print the table. Fair enough. Let's put the breakpoint here. Let's put the breakpoint here. Let's see where we get. Will we hit this line, or will we actually find such a table with that property? We will. That's amazing. Pretty print the table. And okay, it's not really pretty, but listen, not gonna complain. Let's see whether there's any other one. Yeah, that's the only one. Okay. So let me think. How can I fetch cell from a row in the table now that I have access to row information? You have to do TD or something. So it's going to be very similar logic. We just do table find all and then TD block. I could have inferred this myself. Okay. So we just need to do the following. So once we have the row, I'm just going to fetch my table here by using this logic. And once we have the target table, we go target table find all the rows. Let's do something like enumerate, because we want to skip the header. So like if I equals 0, continue, exactly. That was skipping the header. Otherwise, for cell in this, print the cell. Cell index. And we can now just see how this is going to work. Run. Okay, guys. Tables, not table. Sorry, I'm not sure, Future, what you're referring to. It looks like this will work for the cell. We grab, here it is, open subtitles. That's precisely what I was looking for. Open subtitles 2018. The next one will be 46239. Yes, exactly. So what I now want to do is well, I basically just want to grab the first cell. Grab the first cell from the row. And then corpora name is this. And corpora list names is just gonna basically append that. And we're done there. So we have the corporate names, and now we return that back, and I think this was 85 by my count, but I might have made a mistake, so that's why I'm lazy and I wrote a program for me to do the same thing. So like, let's just grab the corpora name, or corpora, yeah, corpora names, sounds good. Let me uncomment this. Well, actually, just let's see what we get here. Well, why not at the same time? Corporal list. We ideally want to assert that the lengths of these two are the same. Okay, let's go. Whoops. We failed. On row 86 we failed because what? What's the last row? Aha, the last row is total. So you probably want to skip that one as well. Let's see. Aha. Wait. What do we get for this? Do we get the list? Aha, it's an empty list. There are no rows here. So I'm going to do the following. TDs. If length of TDs is 0, in that case, continue, although just we could break as well. Okay, this should work. Run. Will this fail? 85, as I said, and this was 86. So my eyes were not, I was not stupid. There is some difference here. So let's just see what the difference is. Print set corpora names. I think we can do it like this as well. We want to see the difference. Well, actually, this one is longer, so we need to do it like this. This should work. And then once we have that set, I think we can just paste it like this. This should work. Let's see. So what's the difference here? Why didn't you give me the difference? Let's just do it like this. Set diff this or difference. Okay. What is going on? Probably different naming. All 86 are different. So what do we get from one? What do we get from another one? Bible in corpora names. Oh, wait, I have to. There are all of these weird. Let me just see the corporal list. CC matrix, and what do we get? We get CC matrix followed by backslash and then some weird stuff with version. So they just apparently just drop. We need to process this additionally. So we have to, anything after the backslash should be dropped. So let's just quickly do that. So we can quickly do corpora names equals corpora name equals. So for element in corpora names, we grab the element, but we split on the forward. Sorry, it was backward, right? Backward slash. Where is that symbol on my keyboard? Here it is. 0. And we'll here have to do double quotation marks apparently. Okay. The parser is complaining, but this should work. Why? Okay, let's just do it here. Directly in here. Corpora names. For element in corpora names, we grab the element, we call the split, we open. What is wrong? Ah, this is escape. Escape symbol. Okay, fuck. This is just a nasty symbol, so you have to do it like this. Rerun. Corporate names. How do we split this? How do we escape this one? Sure, we can always use regex, but can we do it using string split method directly without using that package? This is not gonna work. I think this one might work. This one might just work. But what do we get here? Do we just grab this like this? I'm not sure. Let's just double check. Let's run this. Ah, fuck my life. Can I just do it like this? No, I can't. We have to escape it. Why? If it's set to R, shouldn't it be like literal? Something is weird here, guys. If we do all of this, then it will definitely not work. I'm fairly sure this is not how you should do it. Ah, it's actually breaking it as well. No. Oh my god. Okay. This is one of those minor details that are like super conceptually easy, yet always so much struggle. So I have to, can I just convert it into a raw string or what? Let me see. Um, let's see this. If anybody knows the solution to this, let me know. Okay, this worked. This worked. Because temporary was a representation. Wait, if I just do this then, it can be a quick hack for, it might not extend very nicely, but it might work now. Let's try this. If you know a nicer solution, let me know. This worked. I don't care. So again, let's see this. Difference, length. Why are you different? What's up? What's up? Oh my god, because there's some... Okay, because I've done this representation, we now have this additional single quotation mark. This is the hackiest ever piece of code for a string. But it should work. Ubuntu. Ubuntu is what the corporal list has, what the corporal names does not have. Why? Why is that the case? What's up with Ubuntu? Ubuntu, nowhere to be seen here. Okay, now that we have that, let's start downloading our data and we'll see what happens with Ubuntu. That's how we're gonna do this. So, let's go, guys. I'm gonna later fix all of this. For now, we don't need this. We also, well. What we're gonna do is we grab the corporal list. And next up, we go through the corporal list. And then we just source target file. If it doesn't exist, create. Okay, this should be it, guys. This should be everything we need to download our data to the Opus download folder. And then at the end, we can just delete it. Let's go. we're going to store this into, or let's see what's our usual format. We have the dataset name here, followed by the direction, right? So that means we want to do, yes, we want to do the same format. So let's go and do it like this. So we have output folder, and output folder is going to be output folder. This is going to be the root folder. It's going to be the root folder, and the output folder is well, actually, output folder is going to depend on all of these. So output folder, join the corpus, and then do something like this. But we have to convert the code to BCP47 before we do that, which we can easily do because I've done the work before. Let's see. Root folder, corpus, direction, and then we save the file there. If it does not exist, then we read and save it. Otherwise, we go here. I think this looks good. And we have to do this. Exactly. Download should be download should be just the same location. Root folder followed by exactly Opus download, and then exactly okay, that's it. So we create those two, then we grab the corporal list, and then we go through those, we form the output, and we start saving. This should be it. I'm gonna now delete the opus that were somewhere in here. Opus sold. This is gonna be deleted. Opus as well. Deleted. And let's go. What are we expecting? Size of data again. 57,000 documents. I have no idea how much data this is gonna be, but judging by the number of tokens, we have around 3.6 billion of tokens. Is that? Yeah, 3.6 billion. If every token is some amount of bytes, we're definitely expecting over 10 gigabytes of data here. We're looking to get over 10 gigabytes of data. Let me just quickly check. I didn't clean my Ubuntu. I'm kind of struggling a bit with space. Ubuntu. Space. Well, this is probably the easiest one. System monitor and just see the file system. Okay, I have enough. I have enough space here. Okay. Let's go, guys. We're downloading English to Croatian. I want to catch errors because this will probably silently fail. Let me just quickly go up here. 5 megabytes. Okay, and then download. Well, I guess if any failure happens, we'll raise an exception. Let's just exit here. Exit. Okay, if there is any error, we'll just hit this exception and we'll break. Okay, exit. 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 Nice. Nice. Remove the breakpoints. Exit from here. Done. Let's see what we end up with. So we end up with Opus download, and we end up with English creation and the gzip. Okay. What I want to do before we proceed is just map this into the right format. For that, we need to grab the language mapping, and we need to go from, let me see, this one. Do we have like Serbian? No, we don't. Okay, and then let's see where this is used. One, two, three. Okay. Import from code mappings, this. And then we want to have to BCP 47 this, and then this. Well, let's just create a function that goes from one to the other. Exactly. So we map to here, and then we map to here. I'm gonna refactor this a bit later, but for now, this is gonna do the job. And it looks the same. This one is func, so I have to just do it like this, and then import, and then we do it like this here. Okay, so this should now correct this into the right format, English, Croatian, and we just have that there. And then at the end, I'm gonna just process all of this and make sure we have the correct output. This is gonna give us a single file that's separated by tab. What we could do instead is, if we modify this script, I think it can actually write directly to 2 files. So I think we can actually do that, guys. I think instead of passing a single write file, if we pass 2, as far as I remember, if write is specified as 2 files, let's see, write. If length is 2, then we open up 2 files. Exactly. The source and the target. And in that case, well, let's see if that's gonna work. So let's specify 2 files. The output file name. I'm gonna make it source. If this does not exist, and one more does not exist, so let's just do output exactly. Well, actually, just a second. And this does not exist. Then we create this and this. And then we go and we pass in both of these. Let's just make this a bit more readable here. Oops. Okay, we read that. I just need to change the format here. We should do something like well, let's do the same thing that we do for all of our other, for the download script. We have the corpus name followed by the direction. Let me see. We have the corpus name, init routine, corpus name, what's going to be the file name? Okay, these are the file names. We rename corpus name dot and then the BCP47 code. So let's do the same thing here. So corpus name followed by the BCP47 code. Just do it like this. Corpus name, I think I had a dot. Let me just see here. Yes. Okay. And then TSV. Well, this will not be TSV. This will be different, but it doesn't even matter. That's just a string. Let's see what it is. So let's see whether this works in the first place. So let me delete this from here so we can retrigger the run for this Bible. One, delete this. Let's just see whether this works as expected. Hit run. Okay, here we are. Run until the next iteration and see whether this fails or not. Okay, it looks like it did not fail. And we end up with 2 files. So now if I were to extract this one, let me just go here quickly, just to make sure all of this makes sense. Change directory to here. For example, English. Is this even? Okay, it worked. And as you can see, this is a pure English text. 62,000 lines. Let me do the same thing for Croatian. (62,202), 62,202. That's it. So we just get separated. Instead of writing them into a same file with a tab, why not just directly put it into the format that we use ourselves in the download parallel corpora script? Okay, this makes sense. So let's just make our life a bit easier. Quick break for 3 minutes and I'm back to wrapping this up and just kicking off the download. Let's just stretch the legs for a couple minutes and then we're back. Okay, so quick 3-minute break. Be right back. Awesome, guys. See you in 3 minutes. Okay, let's go back. Let's finish with the logic here. So I'm gonna do the following code, the following thing. Get the source PCP 47 like this, and get the target there as well. Reuse it here. Reuse it here. And then also use it here. And here. Now that we have the gzip, we have to extract it. Let me see how we've done it here. Gzip, extract and remove, open, and then remove. And then file content is written into the zipped path. Fair enough. If we do that, then we just need to have the right format and everything will be sorted out. So we can just grab this function and import it into Opus as well. We should probably extract that to a utils file, but for now, download Perl Corpora, import this, and then once we're done, we call like this and like this, and this is now in the exact same format as what we end up with. This is not TSV, this is not this, so we're gonna end up with the right file name after this called here. Yes, let's test it. Again, I'm gonna delete all of this, Opus download, to force it to start again. Let's go to download Opus and let's just go through one single pass. Make sure this works. Run and see what happens. Here we are. Here's Opus. Here is the data. And then if we do this, something went wrong here. For some reason this failed. The file names are correct. That's the good thing, but we don't have any data. Why? We extract. Let's put the breakpoint here and let's rerun. Let me see, where do we lose our data? Repeat this. Oh no, oh no, oh no. I made a mistake. I always get confused because the namings of these functions are weird. Print pairs actually save stuff. Okay, that was a bad call. So now this should work. I think we're there. We now have everything in the correct format and stuff should just work. We could kick off the run for creation in English, but I want to babysit it a bit. I want to see whether there are any errors. Okay, here we are. Opus. Here's the data set. If we just go and do this, file content, write the content, remove the file, and we're golden. Exit, put a breakpoint here, hit F5, and let me show you the results. Here are the results. Perfect file for English, perfect file for Croatian, and right format. We have the corpus name, we have the direction, we have two files with the corpus name as the prefix and BCP47 as the suffix. And that's the same type of format that we use for our train data. Here's the data here, corpus name, direction, files. Same exact format. Let's just now continue. Okay. Next up, downloading. Oh my god, 39 gigabytes. Okay, I definitely misunderstood how much this takes. So let's see, 40 gigabytes for just a second while it's downloading in the background and eating my bandwidth. Yeah, let's just stop it. I don't want to. I have an optic fiber. It's gonna eat all of my bandwidth. Let me just for a second see where is the. So 39 for CC matrix. Okay. That's because it probably has a ton more. These are the clean versions, right? These are the clean versions. Okay, so let's for now skip the biggest ones and download everything else. So let's skip these 4 names. Ignore list. Open subtitles. CC matrix. NLB. Whoops. ELRC. EMEA. And maybe CC aligned. Maybe we can do something like corpus in case I misspelled anything. Like that, just lower it in case I misspelled anything, or if there is any error in the actual naming of the, yeah, if there is any discrepancy. Okay. Why is CC align being stored here? Okay, because kick it off. Let's go. Nice. Working. Haha. I'm not sure how they envisioned this update function to work, but let's say it's not the greatest experience in the world. DGT, what's DGT? DGT has 0.7 million sentences. It's a fairly big data set. A collection of EU TMs I guess, translation memory provided by the JRC. Let's quickly see here. Let's open up the file, European Community. Let's go all the way down there. 730. Yeah, that was 0.7 million, that's it. Let's go. Nothing failed. Once this is done, we can make an estimate of what's the memory for the data we downloaded. Then we can estimate how much it's gonna take for the rest. Okay. Run. That was a quick one. Let's just keep on doing. I don't see any errors. Later we're gonna examine the data. I don't see any errors. This should not happen. This should never happen. Let's make sure we didn't have that in the output so far. An error occurred. I forgot to add the error. Okay. Looking good. Run. Run. Looking good. We should have made like a raise here, raise exception, so we don't miss it accidentally. And also let me stop this for a second. This should be OR. If either one of them does not exist, we want to trigger it. Here we want to have raise exception, and we also want to print progress. So we want to print something like this, and then corpus, and then this as well. And we also want to put like an index here, and then we want to put enumerate here, and then do like a counter here, and so this should be a counter. Okay, we should be skipping. We should skip everything we processed so far. Yeah, the thing is, these will never exist because we delete them. So instead of that, we need to do something like this actually. Probably not the cleanest thing to do here, but it's always gzip, so we can safely do that. Let's rerun. Now it's gonna just iterate. Okay, loop. And here we are. Let me just see if this happens. We're skipping, and in that case we should say, well, for now let's just copy it like this and then just say oops, just say skipping. Okay, this looks better now. So 0, skipping here, and then let's go. Hit F5. Most of these datasets are small. Let's continue. I'll probably remove Montenegrin from the set of languages. We're gonna probably go just with HBS. Opus does not have enough data for Montenegrin. It just has like 1,000 something sentences, and then I'm not sure about this Makoku dataset. I'm not sure how much it has data for Montenegrin. Okay, it looks good. We're making progress. I don't see any issues so far. After this, we go and download Serbian and Bosnian, and then we transition to the second dataset, and then we can start training, guys. I think until the end of the day, we'll probably be in the position where we can start training. While we have this bigger break now between the second and third stream, I'm gonna just kick off like a download run, and I'm going to catch any exceptions and just log them so that we can later manually go through those. Hopefully there will not be many errors, and then we can just fix that, but the data will be downloaded so that we can start analyzing it both manually and also using the analyze script. And then after that's done, we can kick off the filtering and the data preparation stage. So I think we can kick off a run tomorrow at one point, and that's already the first milestone of the project. So that's amazing. Why is this set? Not sure. I had some weird breakpoint there. let me see what's going on in Discord. Just writing down everything I just said. I'll manually go through the data. Okay, and then looking good. Let me kick off this one. Skim, and then on some go. 500 megabytes here. Let me just scribble down those next to-dos. Let me just copy this from Discord. Okay. Looking good. Okay, these are super small, a couple of megabytes. Okay, creation so far, no issues. Of course, we did ignore the biggest data sets for now. No issues. I'm curious about Ubuntu because it was missing from the table. So they must have some discrepancy there between what's rendering on the website versus this script. So which one? One of them has a wrong database. Let's see. Okay, all of these are super small. Long tail. Power law is real everywhere. Okay, here is the first exception. There is no item named blah blah in this. Okay, so when this happens, empty, append the corpus, and then at the end, save the corpora list. Fair enough. We didn't have to do the duplication here. Just say sorted and then save it to the root folder. Get corpora list. Fair enough. And then we just separate with lines like this. Looking good. Let's retrigger. So we are gonna, I think, hit the same corpus. Yes. Go here and continue. Run. Okay, this is 5 gigabytes. This will take a while. Let me go back here. Let me see which line. Do we have Boston here? Yes. They did not include. Yeah, we will not include Montenegrin. Likely. Because there is not enough data. Yes, it's not included. While we are waiting for this to download, it's actually fairly fast. I have optic fiber, so unless my internet breaks down, sometimes that happens. 83%, it's going very fast. Let's see. Why am I not seeing Uh-huh. Acquire additional high-quality non-public barrel corpora for HPS. Let me think here quickly. Parsing the file. Okay, guys, we are wrapping this up slowly. As I said, I'm going to kick off Bosnian and Serbian. I'm going to see how much data we have and then continue after the end of the in the next stream. What can I do in parallel? Let me just quickly go through this paper while we're reading. Did you see this one, by the way? Large language models as optimizers from Google DeepMind. Take a deep breath and work on this problem step by step. I have some texts along with their corresponding scores. The texts are arranged in ascending order based on their scores, where higher score indicate better quality. Interesting. There's a ton of work going on treating LLMs as a black box and just using them as components. Mojo is apparently live since September 7th, a couple of days ago. High performance Python++ language for compute. Engine, Jupyter kernel, debugging support. The initial release of the SDK supports Linux. Nice. This is gonna be big. Did anyone try it already? Nice. It's amazing. I'm super excited about. Once they add debugger, I'm in. There's gonna be a ton of stuff that's gonna happen on top of Mojo. You see something? I think I shared this work before. Was it the optimizer paper? Yes. Scaling reinforcement learning from human feedback with AI feedback shows that RLAIF can produce comparable improvements to RLHF without depending on human annotators. This seems exciting work as well. What's going on here? Still downloading and processing here. Preferences are labeled by an off-the-shelf LLM in lieu of humans, and we found that they result in similar improvements. But which LLMs? Are they like base models or already instruction tuned? On the task of summarization, human evaluators prefer generations from both RLAIF and RLHF over a baseline supervised fine-tuned model in 70% of the cases. Humans prefer both at equal rates. Interesting. It's a bit worse, apparently. Which model did they use for off-the-shelf checker? Nice. That's amazing. Let's kick this off. Okay, there's a ton of errors here. Parsing, there's some errors. This is GNOME. We already seen, huh? Okay. But here we did not even hit the exception. That's what I was afraid of. I was afraid of such datasets. So okay, this was GNOME. Do we even have it as the output? A, B, C, D, E, GNOME. Something succeeded, but mostly did not. Okay, GNOME is problematic. We've seen that already before. Let's kick it off. Almost done. This is 69th corpus. There is no item named this. Continuing from next sentence file pair. Let me just see something quickly. Copy. Where was this? Actually not there. There was some problems. There is no item named. This one is not even reported. Run. Run. Skipping these two corpuses, which are big. Okay, Paracrawl might take a bit more. 70 gigabytes. That's gonna take a while. Let me stop it. Let me just add it to the list as well. There are roll, and let's rerun. I actually stopped it without saving the bad corpora, so that's bad. Okay, I'll manually have to check a couple of these datasets. As we saw, there are some issues. I'm thinking we should do this manually to catch such errors. I should not run this without supervising it. I'm gonna find where these are. Ideally, we should have saved all of the output to some file and then later parse it. If I do that, then we can easily, if we get somehow overload the print function so we save to a particular file, that would be great. Then I can later just check for any issues. Almost done. Run. Couple more and we're done here with creation. At least minus these big data sets. Okay guys, I think we'll continue this in the next stream. Downloading the data, I really want to redirect the print to not to standard output, but instead to a file. And then maybe we can rerun this whole thing. So that's why I don't want to waste, if we're going to do it again, obviously not on the stream, but just in the background. Let me wait for this one to finish. Okay, guys, that's the plan. See you in the next stream. We're going to continue downloading the data first for HPS, and then we'll take it on from there. Cheers, guys. See you in roughly, let me see, 6:45. I'm aiming at 8:30 p.m., which is in 1 hour and 45 minutes. But go to the OpenLLB channel if you want to keep up to date with everything that's going on with the project and with the streams and everything else. Okay, guys, cheers. Have a nice evening. Have a good night or good morning, depending on where you are, and see you a bit later. Cheers, guys.